Hey guys, we're talking about solving rational equations part 2 today. So we the previous video, we introduced you to this idea of using the LCD to clear out and wipe out all those fractions. And we got really nice, clean, rational answers. Today we're going to kind of use that same process, but we're going to start to get into some irrational answers and some complex answers. The good news is I don't think there's like one mind-blowing new thing about today. You'll notice the questions are going to look very similar in nature to what they did in the last video. But what you're seeing is you'll notice right in the directions here, solve for x to the nearest tenth or express your answer in simplest radical form. Those are indicators that we're going to be using the quadratic formula a lot today. Okay. And we're just going to be simplifying those answers from there. Now we've got the same game plan. We're going to factor all of our polynomial expressions when applicable. And I think right there is a good time to identify what we call your constraints or the restrictions on the domain. In other words, what is x not allowed to equal based on the fact that, we can't divide by 0. And then we're going to get into distributing that LCD, clearing your fractions, and then jumping into the quadratic formula most likely today. So step number 1 says we want to factor all of our polynomials, but I think that's already been, it's kind of taken care of. There's nothing we could really do. When you look at those two denominators, the constraints are going to be x cannot equal 0, x cannot equal -3. And we're just getting a habit of always identifying those little rascals right out of the gate. Now, my LCD in this particular one is going to be the product of x and x plus 3. And I'm going to go ahead and distribute that to all 3 terms here. So we've got our LCD distributed to our first term. Whoa, that's going to be an x right there. And then we'll distribute it to our second term. And it's so much fun to cancel things out, isn't it? And then when I distribute this to the third term, I'm just going to write that as 3 over 1. Okay, so within the first term here, we can cancel out this factor with this factor, and you're just left with x plus 3. Okay, let's see. In our second term here, we can cancel out the factor x plus 3 with the factor x plus 3, and then you're just left with plus x. Now on this third one, there's nothing to cancel out because the denominators are all just 1s. So I'm going to distribute my x to make x squared plus 3x, then distribute the 3 into there. So you'll end up with 3x squared plus 9x. All right, now we're off to the races. We're just going to solve this equation the same way we would have a few months ago. We're going to try to move all the terms. Whoa, got the highlighter going there. We're going to try to move all the terms over to the right side. So we got 3x squared. I got x plus x makes 2x, but when I subtract it from the 9, I get 7x, and then we'll subtract the 3 over. So, one thing we could try guess and check. You're more than welcome to try it. But, anytime the directions indicate solving your answer to the nearest tenth, they're basically telling you, don't waste your time trying to factor. Just get right into that quadratic formula. Oh my gosh, why do I keep doing that? All right. So real quick recap, our quadratic formula is going to be -b plus or minus the square root of b squared minus 4 times a times c over 2a. And let's see, we're going to substitute a 7 for b, and 7 squared makes 49. And we'll substitute a 3 for a and a -3 for c, all over 2 times 3. All right. One thing I like to do is just plug everything that's underneath the radical into my calculator all at once. And gosh, I did it again. I'm going to lose my marbles. All right. So underneath the radical, see if you're getting the same thing. I got 85 underneath the radical there when I did 49 minus 4 times 3 times -3. Now, a lot of times we'd get to this point and we would try to simplify the square root of 85, wouldn't we? Okay. The good news in this particular case is we don't even have to even entertain that thought because we're trying to solve to the nearest tenth. So what I'm going to do is I'm going to grab my calculator And I'm going to type in -7 plus radical 85 divided by 6. And I encourage it on your TI-84, take advantage of that alpha F1 feature to set it up as a fraction. And let's see what we're getting here. And I'm going to go, so I'm getting like 0.3699, yada, yada, yada. If we round that answer to the nearest tenth, use my approximation signs, we'll get 0.4. Okay, so there's one hopeful solution. And then on the other side, we'll do -7 minus radical 85, divide that by 6. One nice thing on that calculator is you can just kind of arrow up twice. It kind of copy and paste it so that all you have to do is change that one plus sign to a minus sign. And I got -2.7032. We'll round it to the nearest tenth, and we'll say we're getting -2.7. So let's say now 0.4 and -2.7 are our final answers there. All right, cool beans. So again, everything, these denominators are already factored for us. So ask yourself, what's my LCD going to be and how am I going to distribute it? But first, before I get too far, let's identify the constraints, right? X cannot equal 0. X cannot equal -1. And of course, if I got either of those answers, I would reject it. But I think I'm going to get much messier answers that are in radical form. So this is a great time to maybe hit that pause button and see if you can solve this one on your own. So I'm going to go ahead. My LCD is the product of x and x plus 1. And I'm going to go ahead and distribute this to the first term. And then I'll distribute it to the second term here. And we'll distribute it to the 7. All right. So within that first term, we can cancel out the x again. And then distribute the 4 to get 4x plus 4. We'll cancel out the x plus 1s, right? Let's see here. So we'll multiply the 3 and the x to get -3x. And then at the tail end here, nothing cancels, so I'll distribute my x and then distribute my 7 to get 7x squared plus 7x. We'll go ahead and we'll try to move everything over to one side. I bet you're really feeling the rhythm here. I bet you're feeling the rhythm. Starting to build some confidence here. Of course, if I combine the 4x and the -3x, I'll get x subtracted over to get 6x, and then we got a -4. So unfortunately, there's no GCF, and I'm going to jump right into my quadratic formula. And again, maybe you didn't hit the pause button earlier because you still weren't 100% confident in yourself, but now I think here's another great time to hit that pause button. 4 times A times C, okay, all over 2 times 7. And let's see, what are we getting underneath that radical? So in my calculator, I'm going to do 36 minus 4 times 7 times -4. That's giving me 148. So now the $1 million question is, of course, I don't think 148 is a perfect square, so that's bad news. So let's try to figure out the biggest perfect square that does divide nicely into 148. And I just tried a bunch of random guesses on my calculator. It wasn't divisible by 16 or 64 or 36, but it was divisible by 4. So what I'm going to do is I'm going to do radical 4 times radical 37, which makes -6 plus or minus 2 radical 37 over 14. And you'll notice each term is divisible by 2, so we'll go ahead and reduce it by a factor of 2. And now there's my final answer, and I'm going to leave it in simplest radical form. Okay, one more crazy bear. Now you'll notice in the directions here, they said express your roots in simplest a plus bi form. So I'm still going to use the quadratic formula, but now we're going to get some imaginary numbers, some complex numbers. So we're definitely expecting to get a negative number of some sorts underneath the radical within that quadratic formula. Now, as far as constraints go, I'm just looking at this one denominator. And so I'm going to say x cannot be 0. And then what do you want to use for your LCD? I think I'm going to use the product of 5 and x. So I'll go 5x, and then we'll go ahead and distribute it. Again, maybe you're starting to build some confidence and you're ready to tackle this bear all by yourself. Feel free to work ahead here all by yourself, and we'll see if we get the same answer. And then we'll distribute it to the very last term. Okay, let's see what we got cooking here. On the first term, we're going to cancel the 5s and then distribute this x into the x plus 8. Okay, on the second term, I'm going to cancel the x's and then distribute the 5 into the x plus 5. And then, of course, on that third term, nothing cancels. In this case, we would just get 5x. All right, let's see if we can move everything over to the left side here. And it looks like I'm going to get x squared. If I subtract the 5x over, I just get 8x plus 25 equals 0. Naturally, my knee-jerk reaction is to try to factor that. But again, the direction said we're looking for answers in simplest a plus bi form. So you just skip that thought altogether, and we want to get into that quadratic formula as efficiently as we can. So we're going to negate the b term. Then we're going to square the b term. Minus 4 times 1 times 25 all over 2 times 1. Okay, so I'm thinking negative 8 plus or minus. So on my calculator, let's try 64 minus, well, it looks like 100. So I'm getting negative 36 right there. And we were definitely expecting a negative. If you got to that point and you hadn't gotten a negative number, then that's kind of a red flag, and we'll just kind of work backwards and try to find a tiny little mistake that'll straighten things out for us. All right. So we've got negative 8 plus or minus. If you recall, simplifying these radicals with negative numbers underneath them, you're going to get 6i. So we're going to, and then everything's divisible by 2. So we'll say negative 4 plus or minus 3i is my simplified answer. And there it is. So again, hey, there's no substitute for some great quality reps, and that's what we're going to build on. When we jump into class tomorrow, we'll try 1 or 2 more, maybe more challenging ones, and then we'll turn you loose and let you show off a little bit and do your thing.